Hello, welcome back to my channel. Today I'm going to take you through the thought process behind my URP Volumetrics, which you can grab from a link in the description. You can see here in the first section we've got SDF metaballs, a bit of stylized fog, baked SDFs, searchlights, and light shafts. In the middle you can see an example of lit volumetrics, and in the second collection we have more stylized options, including this cool fire effect. I thought I'd quickly take you through the principles of a few of them and how you can go about modifying and improving them. Firstly, though, we're going to need to recap what SDFs are and exactly how ray marching works. In effect, ray marching is imagining the camera as a grid of pixels, all firing beams in different directions to give the illusion of perspective. We then sample at discrete intervals along each beam to discern the color of the pixel. SDFs are signed distance functions. Effectively, they depict the world as a big formula where being inside an object has a negative value and outside an object has a positive value. The key part comes from the fact that the magnitude of the object is how close it is to the nearest surface. We can use this data to optimize our ray marching. If we know that the nearest surface from our camera is 30 meters away, then we can safely travel 30 meters in a direction before we need to worry that our beam is inside an object. We can make SDFs using functions, and there's a handy website full of them in the description. We can also use Unity's visual effects graph package, which includes an SDF baking tool, which will create a 3D texture containing the correct positive and negative values, all from a mesh. With that, let's go through the shaders. A stylized gas uses SDF functions to smoothly join spheres together. To get the thickness of the volume, and thus the density of the gas, we simply ray march from the mesh surface in the direction from the camera. However, once the SDF function returns a negative value and we've hit the surface, we then fire a ray from behind the object towards the camera. Most volumetrics just ray march through the gas to get thickness, but as this is stylized, I'd rather it was performant. The lit mist is more traditional, but still a little complex. It samples the SDF function to find how far the ray can travel before sampling again, and then upon hitting the SDF, it switches to sampling at discrete intervals to get density and the lighting at that point in the mist. The baked SDF displayer uses a 3D texture generated from the VFX graph package, but otherwise marches through it the same as the lit mist, only the ray must be transformed into the object space of the SDF. This matrix is set up by a C# script, which also optimizes the mesh. The light shafts and the fire are a little different. They don't use SDFs and instead calculate collision points between the cube mesh and the incoming camera ray. They then ray march between the collision points. This is performant, but I think it can lead to weird results, as no matter the length of the segment being ray marched, the sample count is constant. Anyways, the shafts simply sample against a 2D texture, and the fire samples against an SDF vesica and a noise texture being transformed by time. The issue with most of these objects is they don't hold up when the camera moves through them. This could be fixed in a number of ways. Firstly, you could draw back faces instead of front faces and ensure the object is always drawn by enabling z-test always. Then, calculate the depth of your volumetric surface and use that to manually discern if your volumetric should be visible or not. You can use this function in HLSL once you've found the surface of your SDF and compare it against the scene depth node. Alternatively, you could transition to a full screen effect, fading out the volumetric as the player gets closer, and fading in some post-processing. Anyways, this is a pretty rushed video, but I hope you use the shaders and take time to look through the code. It's definitely unfinished and a lot of improvements can be made, but I hope it's helpful to you, as I was unable to find many free resources about Unity URP Volumetrics.